Welcome to the Planet of Maths channel. In this episode, we will talk about multiplying and dividing rational expressions, like these here. On this first fraction bar with this x squared, we will basically do nothing. And at the bottom, 2x minus 4, we can factor out a 2 here. When you factor out the 2, in the parenthesis from this part, we'll have x left, minus we rewrite, and 4 is 2 times 2. So, from 4, when we factor out a 2, 2 remains in the parenthesis. On the second fraction line at the top, 4x minus 8, you can factor out 4. The number 4 goes outside the parenthesis, then inside the parenthesis we have this. From 4x, after taking out 4, we're left with x. And from this 8, since 8 is 4 times 2, when we took 4 out of the parenthesis, 2 remains here. And in the denominator, x squared plus x. Here we take x out of the parenthesis because this x appears here and here. We factor out x. In the parenthesis, there will be x to match x squared plus 1 to match x. X times 1 gives us x. And now things like this happen. We have x minus 2 in parentheses here, and we also have x minus 2 in parentheses here. So this parenthesis and this one, they completely cancel out. The 2 here also reduces with the 4, leaving me with 1 here and 2 here after reducing by 2. But we also have to notice that x squared is x times x. And then one of these x's with the x on the bottom also gets reduced. This 1x here and this x here, they cancel each other out. So the effect is that if I have x here, I cancel it out, and here x squared, I can also do it so that the square cancels out, and I'm left with x at the top. Here I have x left, here a 2 will remain, so I multiply x by 2, I get 2x from this. At the bottom, this I reduced, this I reduced, this I reduced, only x plus 1 is left. The formula for the difference of squares. This formula looks like this, or it can also be written in reverse order, like this. In this form, the formula works such that if we have two brackets, identical brackets, only differing in sign, then we can make it so that the first thing from the bracket, we raise it to the second power, meaning x squared. Then according to the formula, there's a minus, and then it should be b squared, which for us is this 5. Raised to the power of 2 gives us the result 25 from 5 squared. Just for practice, here I have two identical brackets, there's x and there's 9. Here it's plus, there it's minus. Here the order of pluses and minuses doesn't matter. First, I raise x to the power of 2. I give the minus sign and raise 9 to the power of 2. That's 81. This is how this formula works in this direction, and now how it can also work in the other direction. If we have something like x squared minus, for example, 16, we can do it this way if we notice that 16 is 4 squared. So we have this difference of squares. Here we have one square, the other square, and subtraction. So thanks to this formula, I can write it like this. In the first parenthesis, I write what was here, x minus 4, but without those squares, so x minus 4 in the first parenthesis, and in the second parenthesis the same, but with a plus, so x plus 4. Having such a difference of squares, I can change it into two parentheses. We'll practice this again in this example. Here we have x squared minus 4. This 4 is interesting because 4 is 2 squared, so we'll do the same again. Write down what's here but without squares, and in the first parenthesis, x minus 2. And in the second parenthesis, what was here but with a plus. That's how the formula for the difference of squares can work. In example B, I have something like this. 4 stays at the bottom, nothing changes here. And at the top, I can factor something out. I have a 3 and a 9, so I can factor out the 3. Then, inside the parentheses, I'll get 3x. After taking out the 3, x is left. I write down the minus, and after taking away the 3 from the 9, I have 3 left, because 3 times 3 equals 9. The second fraction, on top 8 does not change, and at the bottom, x squared minus 9 is x squared minus 3 squared. Here instead of this difference of squares, I will write x minus 3, which is what was here but without the squares, and in the second bracket, x plus 3. And now it's nice because the parentheses have repeated. I have such a parenthesis here and here, so this parenthesis cancels out with that one. The 4 also cancels out with the 8. From the 4, 1 remains after dividing by 4, and from the 8, 2 remains. The final result will be, on the top I have 3 and 2, I multiply this, getting 6. On the bottom, there's nothing left. This parenthesis disappeared, so only this parenthesis x plus 3 remains. And that is the end of example B. In this example at the bottom, on this first fraction line, we know what to do. Here we have 3, and here we have 12, so I factor out the 3. In the parentheses, I'm left with x from the first term and 4 from the 12, because 3 times 4 is 12. Up here, I have a different order than here at the bottom. First, I have x and then the number. And I would like to have it the same way here, so I will factor out the minus in front of the parenthesis. If I took the minus out before the parentheses, now I have to put a negative 3 inside the parentheses, so that the two negative signs give a positive 3, and x has to be positive then. Simply, the signs with the x changed. On the second fraction line, I write x squared minus 4 squared, because I notice that 16 is 4 squared, and below is x squared minus 3 squared, because that is 9. Now here, inside the bracket at the top, I'll switch the order. I'll write the x first. It's a positive x, so I write x, and then I write the 3, which is negative, so minus 3. That's how it will be on top. Nothing happens at the bottom. Here I have the difference of squares, so I change it into two parentheses. In the first parenthesis, x minus 4, without those squares. And in the second bracket, it will be x plus 4. And at the bottom, I will have something similar, x minus 3 in the first bracket. So is here, but without the squares. In the second bracket, x plus 3. And now we look and quite a bit should cancel out here. X minus 4, I have a bracket here and here. So these brackets cancel out. This bracket also cancels out. X minus 3 and x minus 3. One from the top, one from the bottom. And I actually write down the result. I still have a minus up here, and I have this bracket. And what do I have left on the bottom? I have a 3 left, and this bracket. That's the result for example C. Example D. Here is x minus 2 squared on top. I won't change it for now. Below you can see a 5 here, and in 10 there's also a hidden 5, so I'll factor out the 5. From this I get x, and from that I get 2, because 10 is 2 times 5. The second fraction line, on top I have x squared, here I have 2x, so x can be factored out. In the parentheses, from x squared, x remains, because x squared is x times x. One x was taken, one x remains. Here, I took away x, so 2 remains. And here at the bottom, I'll have the difference of squares because it's x squared minus 2 squared. And to make it clear and explicit, this square of the parenthesis means that it is a parenthesis x minus 2 multiplied by another identical parenthesis x minus 2. I rewrite it this way, and at the bottom, I have 5, and in the parenthesis, x minus 2. The second division bar at the top doesn't change, but at the bottom it changes because here, thanks to the special product formula, we can write two parentheses. In the first parenthesis, x minus 2, that is, without these squares. And in the second parenthesis, x plus 2. And we're finishing the example because a lot of things cancel out here. Namely, the x minus 2 parenthesis and the other x minus 2 parenthesis cancel out. Another x minus 2 parenthesis, I have one more x minus 2 parenthesis at the bottom, so that also cancels out. And the bracket x plus 2 also cancels out for me. Here I have x plus 2, there I have x plus 2. It cancels out. On top, there's only x left, the rest has canceled out, and on the bottom, there's 5 left, because the rest also canceled out. So that's the result for our example D. The formula for the square of a sum, or also the formula for the square of a difference. These are formulas, and they work in two directions, just like here or just like here. Just like here, it works when we have a bracket. In this bracket, there is addition or subtraction, and we are to raise it to the power of 2. According to this first formula, we first need to square the first item from the parenthesis, which is x squared. Then you copy this sign, which is plus. And then it's called a doubled product, meaning we take the product of x and 4, what we have here in the parentheses. X times 4 is 4x, but it has to be a doubled product, so I double this 4x, resulting in 8x. And finally add b squared, which is add 4 squared, that will be 16. This 16 is 4 squared. Another example. I have a parenthesis inside the parenthesis subtraction, and all of these squared. So now, according to the second formula, it goes like this. X squared first, then that sign, and then there should be again that doubled product. So I calculate the product of x times 5, which is 5x, and I need to double these 5x, and I get 10x. I write it here, and finally there is a plus again. The 5 needs to be squared, which will be 25. This is how these formulas work in this direction, and now how the formulas work in the other direction. Here we have to notice perfect squares. If we have such a quadratic trinomial, here at the beginning we have a square, and here at the end we would also have a square. It would mean that we can use the formula here. And the number 25 is a perfect square. It is the square of the number 5. Instead of 25, we look at it as 5 squared. And now we have exactly what is in this formula. We have a squared at the beginning and b squared at the end. We'll check the middle in a moment. Then we do it like this. We put brackets here according to this formula. It should be a plus b here, which means what is at the beginning without the square, which is x, plus what is at the end without the square, which is 5. And all of this squared. That should be correct, but we're not sure yet. The beginning matches, the end certainly matches. We need to check this 10x for a moment, and we check this 10x like this. X times 5 is 5x. And according to this formula, we have here the doubled product, so if you double these 5x, it should give us 10x. And that's exactly how it comes out here, so everything matches. In this example, we notice that this 4 is 2 squared, so according to the second formula, it might be like this. We take x without the square, we take 2 without the square, and we take this sign from here, and we square all of this. It should match. We only need to check the middle, and the middle has to be the product of x times 2, which is 2x, and when you double this product, according to the formula, 2x doubled gives 4x, so everything matches here. Example E looks like this. At the top, the 2 minus x is again a weak order because the number comes first, then the variable. And here, everywhere I have x at the beginning, so I switch the order. So, I factor out the minus sign, then this 2 must be negative, and this x, as if negative, will now be positive. Here at the beginning, I have a square, and at the end, I have a square. Here was a 4, I change it to 2 squared. And at the top, there will be another formula we've already talked about because it's x squared minus 4 squared, and we'll soon convert it all into parentheses. Here at the top in this bracket, we'll change the order so that it suits us, meaning x positive first, then 2. Here at the bottom, since I have a square here and here, I will now write this x without the square, and at the end, I will write 4 without the square, and take the sign from here, there's a plus, so there's also a plus here, and all of that squared. On the second fraction line at the bottom, there will again be x squared, so I write x. Here is 2 squared, so I write 2, and take the sign from here, which this time is minus. This is squared, and at the top, the formula for the difference of squares. So here, we make 2 brackets from this. The first bracket is what's on top without these squares. X sum minus 4, and the second bracket is x plus 4. Now I reduce. Here I have a bracket x minus 2, and here I have x minus 2 squared. So I have 2 such brackets on the bottom. I reduce one of these brackets. I can do it in such a way that I reduce the square with this bracket, and similarly, here I have 2 such brackets. And here I have 1 such parenthesis, so I simplify this 1 parenthesis from the top and the 1 from the bottom this way, and I am left with x plus 4 on the bottom, without the square. Here, I'm left with x minus 2. And up here, I have a minus from the first numerator left, and from the second numerator, I have x minus 4 left. This is the result for example E. Now a few examples of division, but they are not that different from the multiplication examples. You just have to do one thing. First, I change division into multiplication. The first fraction remains the same, and I flip the second fraction upside down. So now the 6 is on the bottom, and at the top, there's 9x minus 6. That's the beginning of my example. Then I'll do this. I won't do anything with this 4, and I won't do anything with this either. So the first fraction does not change. In the second fraction, the 6 will stay on the bottom, and at the top, I can factor out a 3 from this 9x minus 6. It will be a 3. And in the brackets from 9x, I will have 3x left. And from 6, I am left with 2 with a minus. And everything would be fine, except I forgot to change the order here, because this and this are very similar, but the order is not as it should be, so I quickly do what I did in the previous examples. The effect of this will be that the 3x will be at the beginning and the 2 will be at the end, and both expressions have changed signs. Because if we remove the bracket, the minus changes the sign at 3x, and that's it. And this minus and that minus give the positive 2, which we have here. So now I have the order that I wanted. And so I simplify. I have this parenthesis here, and I have this parenthesis here, so I simplify these parentheses. I also simplify 6. I can simplify 6 with 3, there will be 1 here and 2 here. And this 2 will further simplify with 4, so I simplify with 4, leaving me 2 here and ultimately 1 here. So what is left? I have the minus that was here at the bottom, at the top I have 2, and at the bottom, essentially 1. So the result is negative 2. In example G, we have something like this. I could essentially leave that first fraction unchanged, but I'm already preparing, and I'll change 9 to 3 squared. And here I need to take the reciprocal of this fraction, because I changed division to multiplication by the reciprocal. On the top, it will be 3x plus 9, and on the bottom, it will be x squared minus 4. At the top, x minus 2, I won't change that. I can just add brackets because it will be probably simplified. At the bottom, I have the formula for special product, so I look at the beginning, write x without the square. At the end I look, write 3 without the square, and I write this sign in the middle. It will be in parentheses. And these squares from here and here, they go outside the parentheses. Here at the top, I can take 3 out of the parentheses, and inside the parentheses, I'll get x plus 3. Because 3 times x is 3x, and 3 times 3 is 9. Here I have x squared minus 4, which is the same as x squared minus 2 squared. So instead of this here, I write in the first parenthesis, x minus 2, that what was here without the squares. In the second parenthesis, x plus 2, which is what was here but with a plus. And now for the simplification. The bracket x minus 2 and the bracket x minus 2 cancel each other out. The bracket x plus 3 is canceled. Here are 2 such brackets, so I cancel 1 by crossing out the square. Only 1 such bracket remains. So ultimately, everything is simplified at the top except for the 3. And at the bottom, everything canceled out except this parenthesis and this parenthesis. In example H, I'll start by changing this division to multiplication, and here I'm already getting ready for what's coming next. 27 is 3 to the third power. I change this 9 to 3 squared. I do the multiplication, and here I flip this fraction upside down. X minus 3 on top, x plus 3 on the bottom. Here at the bottom we have the special product formula for the square of the difference, meaning this x without a square, this 3 without a square, the sign from here, which is minus, and this is squared. This fraction doesn't change. It is x minus 3. I can just write it in parentheses, and x plus 3 also in parentheses. Here is another formula, the formula for the sum of cubes. This is the same formula here at the bottom, and this is how the formula works. A to the third plus b to the third. Then in the first parenthesis, I write a plus b. In our case, a and b are x and 3. So here I write x plus 3. And in the second parenthesis, what should I write? It should be a squared, meaning what's in this parenthesis, x squared, or this x squared. Then there is the minus sign, because we are using the lower formula. There's a minus, and I have to multiply a by b, which is what I have here in this parenthesis. I multiply by itself. This times this, meaning I multiply this x and that 3. From this, I get 3x, and at the end, there's b squared, which is here. So this is our 3. I raise this 3 to the power of 2. That will be 9. 3 squared is 9. I have the bracket x plus 3 on the top. I have the bracket x plus 3 on the bottom, so I definitely simplify that. And here are 2 such brackets. X minus 3 squared is 2 such brackets. There's 1 such bracket on the top, so I simplify 1 bracket from the top and 1 bracket from the bottom, leaving me with the second bracket on the bottom. X minus 3 remains in the denominator, and what's left on top is what's in this parenthesis. That is x squared minus 3x plus 9, and that's the end of the example. I move on to the last example in which I have a lot of formulas. Here, I quickly convert all these numerators and denominators into powers except for this one. This one, I could convert it here like this. 4 is 2 squared. So theoretically, I could get this. I write this x in front. I write the 2 afterward. Square it. Take the sign from here. But it won't match because here x times 2, when I multiply it, gives 2x, and 2x doubled should give this result for everything to match. But here, it doesn't work, because if I doubled it, it should be 4x here, so there would be a special product formula up top if we had 4x here, but with 2x, this can't be done using the formula. And we just have to rewrite it. Here I was preparing for the special product formula, x squared, 4 squared, so in parentheses, x, the one from the beginning, in parentheses 4, the one from the end. Here from the middle, I take the sign. After the parentheses, I square it. Here I had the formula for the difference of squares. Here it goes such that it becomes 2 parentheses. In the first parenthesis is what's on top, but without the squares. In the second bracket, what is above, but with a plus and without squares. And below, it will be this third new formula, namely the formula for the difference of cubes. So this is the formula. Here, since I have x to the power of 3 minus 2 to the power of 3, which is a to the power of 3 minus b to the power of 3, x is a, and b is that 2. So I first write down what's here, but without raising it to the power of 3, which is a minus b, in my case, x minus 2. And in the second parenthesis, I write a squared. My a is x, so x squared. I write the plus sign, then it should be a times b, which means I have to multiply what I had here, so I multiply x times 2, and this results in 2x, and at the end, there is b squared, our b is that 2. 2 raised to the power of 2 gives a result of 4, and it so happens, not quite accidentally, that this expression I have here in the parentheses, I also have up here. I will treat this as a bracket and cancel the entire larger bracket on top and the entire larger bracket at the bottom, because these brackets are identical. X minus 2 doesn't cancel with anything, and these x plus 4 are 2 such terms, but at the top I have 1 such term, so I cancel the one from the top and one from the bottom, leaving me with just x plus 4, 1 such term. So at the bottom, x plus 4, 1 such term, then I still have x minus 2. And on the top, I only have the expression x minus 4, but here I don't need to write the bracket because there is only this one expression. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Mass channel.